The National Electrical Code does not specifically dictate how long cable can remain unenergized after installation. It does, however, provide requirements for the storage and installation of electrical cables. Cables should be stored in a dry, protected location, avoiding excessive heat, moisture, and mechanical damage. Cables should be installed according to the manufacturer's instructions in a way that minimizes damage and provides proper support. Leaving cable unenergized for extended periods can lead to certain issues, even though the NEC does not provide a specific timeline. Moisture can penetrate the cable's insulation over time, especially if the ends are not properly sealed. This can lead to electrical breakdown and insulation failure. The insulating materials in cables can degrade chemically over time, particularly in the presence of oxygen and ultraviolet light. This weakens the insulation, reducing its ability to withstand electrical stress. Unenergized cables are more susceptible to physical damage from rodents, insects, or accidental impacts. To mitigate these issues, firstly, energize the cable as soon as possible. This establishes an electric field within the insulation, reducing the risk of moisture ingress and chemical degradation. Secondly, properly seal the cable ends. Use heat shrink end caps or other approved methods to seal the ends of unenergized cables, preventing moisture penetration. Thirdly, inspect the cable regularly. Conduct periodic visual inspections to check for signs of damage or degradation. Fourthly, consider the manufacturer's guidelines. Cable manufacturers may have specific recommendations for storing and installing their product. It is important to follow these guidelines carefully. If cable has been installed for an extended duration and remains unenergized, the following steps are recommended. Firstly, conduct a thorough inspection of the cable, including the splices and end caps. Secondly, consult with the cable manufacturer for the guidelines on extended storage. Thirdly, energize the cable as soon as possible to establish an electric field, preventing further degradation. And fourthly, monitor cable performance closely after energizing to ensure there are no issues. Cables can experience issues with moisture ingress, particularly if the cable ends are not properly sealed. Moisture that penetrates the insulation can lead to electrical breakdown and insulation failure over time. The cable's insulating materials may also undergo chemical degradation, especially when exposed to oxygen and ultraviolet light. This degradation can weaken the insulation and diminish its ability to withstand electrical stress. Additionally, unenergized cables are more vulnerable to physical damage, such as that caused by rodents, insects, or accidental impact. To reduce the potential of these issues, the cable should be energized as soon as possible. By energizing the cable, an electric field is established within the insulation, which reduces the risk of moisture ingress and chemical degradation. Proper sealing of cable ends is also critical. Use heat shrink end caps or other approved methods to effectively seal the end of unenergized cables, thereby preventing moisture penetration. Periodic visual inspections should be performed to identify any signs of damage or degradation. Cable manufacturers typically provide specific recommendations for the storage and installation of their products. Carefully adhering to these guidelines is essential. When a cable has been installed for an extended period without being energized, it is recommended to conduct a comprehensive inspection of the cable. This inspection should include careful examination of the splices and end caps to detect any signs of degradation or damage. It is also advised to consult with the cable manufacturer for their guidance on extended storage, as they may have specific recommendations or concerns related to the particular cable type and installation conditions. After taking these steps, the cable should be energized as soon as possible to establish an electric field that will help prevent further degradation of the insulation. Following energization, it is important to closely monitor the cable's performance to ensure that there are no underlying issues that could compromise its reliability. The type of cable is very important when considering proper storage. 15 kilovolt EPR cable, or ethylene propylene rubber cable, is a specific type of medium voltage power cable commonly used in electrical distribution systems. EPR is a synthetic rubber insulation material known for its excellent electrical properties, flexibility, and resistance to heat, moisture, and chemicals. 15 kilovolt EPR cable is designed to operate at a voltage level of 15,000 volts. This voltage rating indicates the maximum voltage that the cable can safely and reliably carry. EPR insulation provides excellent electrical insulation properties, ensuring minimal leakage current and preventing electrical breakdowns. EPR is a flexible material, making the cable easy to handle and install, especially in tight spaces or complex routes. EPR cable exhibits good resistance to heat, moisture, chemicals, and abrasion, making it suitable for a wide range of environmental conditions and applications. EPR cable is commonly used in underground distribution systems to transmit power from substations to transformers or other distribution points. EPR cable can be installed in ducts, conduits, or directly buried in the ground, depending on the specific application and installation requirements. EPR cable is used in industrial facilities to power equipment, machinery, and other electrical loads. EPR cable is employed in commercial buildings to distribute power to lighting, HVAC systems, and other electrical devices. EPR cable can also be used in renewable energy systems such as solar and wind farms to transmit power from the generation source to the grid. When installing 15 kV EPR cable, it is important to follow all applicable electrical codes and standards such as the National Electrical Code, as well as the manufacturer's recommendations. Proper cable preparation, termination, and splicing techniques are essential to ensure reliable and safe electrical connection. Cable should be adequately supported and protected to prevent physical damage during and after installation. Cable should be routed away from heat sources, sharp objects, and areas where it could be subjected to mechanical stress. Terminations and splices should be properly insulated and sealed to prevent moisture ingress and electrical breakdown. The cable should be tested after installation to verify its integrity and proper operation. Regular inspections and maintenance should be performed to identify and address any potential issues before they lead to failures. When dealing with medium voltage power cables like 15 kV EPR, it is important to hire qualified and experienced electrical contractors who are familiar with the specific requirements and best practices for cable installation and maintenance. Working with medium voltage systems can be dangerous, so it is important to take all necessary safety precautions to prevent electrical shock or other injuries. Some of the safety precautions include wearing appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. De-energizing the cable and equipment before working on it, and using proper grounding techniques to prevent electrical hazards. Additionally, following lockout and tagout procedures to ensure that the cable and equipment cannot be accidentally energized while work is being performed. Furthermore, maintaining a safe working distance from energized cables and equipment, and being aware of the potential hazards associated with medium voltage systems. Remember that proper cable management practices are crucial for ensuring the long-term reliability and safety of electrical distribution systems using 15 kV EPR cable. While the NEC does not explicitly state acceptable timeframes for leaving cable unenergized, following common sense practices and the manufacturer's guidelines will keep risks to a minimum.